YouTube final update on this RPG motor for anyone else that's building one of these. This is a replica attempt of the Mike Clark Paul Babcock RPG, which is really just a air core pulse motor, and it's based on the classic Bedini circuitry. Just for a quick run through for it, this one here has got 6 poles in the rotor. They're all south-facing out. It's got 9 coils. They're all wired in series. It's running off one MOSFET here. Okay, it's triggered by this Hall switch, but we're using a pulse width modulation little circuit that was breadboarded there. I can send that. I can send that to anyone that would like to see it. This is key to really getting the efficiency up, keeping the pulse width quite low. Okay, this is the battery swap here. There's a number of ways to do it. This way I've figured out with a lot of headaches, but it works very well. These are SSRs. They draw very low power. You can switch them at higher voltages. They won't burn up. And then the negative side of the batteries is using high voltage diodes to control the flyback. A really sloppy drawing of it is right there. You take a picture of that and study it, it'll make sense to you. And then this is just a timer you can get off of Amazon to switch them. But anyhow, most of the electronics are run through this transformer here, so it's just running off battery power. These are the banks here. You can see 61.2, 60.2. Okay, they just flipped now, so see that one's going to climb, 60.6. Right, that one's going to drop. I've got supercapacitors on the lead battery of each bank just to help absorb that shock from the flyback. That's really the basic system. It's using this circuitry here. There's different ways you can do this. I've found you can make them work exactly the same in terms of overall performance. I do kind of prefer this one because the drive battery only discharges once, whereas here, every time it discharges, the flyback also goes through the drive battery. It's really just standard Bedini stuff, but that's the basis of the circuit. But what I also wanted to show here is the efficiency of it. So I know people have reported that these will run forever and the batteries won't go down. I haven't been able to replicate that. The best I can do is about 60% efficiency. I'll show you what it's at right now. So if you put a clamp meter, so this green line here would be the input amperage. So I'm actually measuring that right here. You don't want to measure it here because you're going to measure the flyback in that number. So you measure it here coming out of the MOSFET. And you can see right here, this is running about 1.2 amps. You have to move the decimal, about 1.2, okay? And then if I put the clamp meter on the flyback, so this is coming after that diode, it's about 0.47, right? 0.48, and again, compare that to this, 1.16, so it's between 40 and 50% efficient, somewhere in there. You have to multiply the voltages, which are going to bring the amperage up on the recovery, but it's nowhere close to 100. So if the amperage doesn't get to 100% of what you're using, the battery banks will never maintain, they'll eventually go down, right? And the other piece to this is you can run a small generator off the back side of it, right? And I don't have a belt on this right now, but this will do about 10 watts. And I just have it using a charge controller to run a 12 volt battery, keep it charged up. That actually runs the lights in here. Anyhow, there's no point in running the generator coil if these batteries drain down. If the batteries drain down, then it's, an inefficient DC motor, basically. But a couple other things just to point out. Depending on where you measure the current, you can get different values, and so you have to make sure and measure it at the right spot. This is actually the current going in to the circuit, and you can see there's a spike in that, and that's because I'm measuring it before the MOSFET. So it's actually got the flyback spike is in that green line along with the drive spike. So you have to make sure you're measuring the right location. Here again would be just the flyback. You can see it's much skinnier. It's very high, right? So it's getting up to about 9 amps for a very short duration. And then again, this is after this is the source of the MOSFET going back to the negative of the battery. You can tell it's wider. It also is about 9 amps on the peak, about 1.8 average. I'm sorry, 1.2. And then in here, this is just on the drain, or you might call it the collector of a transistor. Zoom that in a little bit. You can see the circuit is off all in this time, right? And you still get this hump here because of just the induction of the magnet whizzing by the coil. In fact, one of my friends that's working on this can get his pulse motor up close to 90% efficient. Just getting this induction to backfeed to the battery. But when the circuit actually turns on, it drops off right here just for a brief time. You can see the current spike feeding pops up. MOSFET shuts off. It slams, that magnetic field collapses. You get boom, slams up. You get your spike. And that's kind of what the waveform looks like just in the classic Bedini setup. Now the more you reduce the pulse width, you'll kind of spread out the bottom when the motor's on, circuit's on. You can see that spreading out. You can hear the motor speeding up. See now it's up. It's going to push 900 RPM. But efficiency-wise, it doesn't get any better. In fact, what I found is it works a little bit better at the lower speeds. So now we're pulling about 1.4 on the feed. Let's measure the flyback. See about 0.5, so now it's closer to 1/3. So I found that the lower the pulse width, the more efficient the circuit becomes. So anyhow, if people have questions and they're trying to build this, maybe they've watched the RPG video from the Science Forum. I cannot get it to work, and I think I'm moving on to something else. It's a really fun project. Making the rotor to be well balanced is very difficult. Figuring the switching out here can be very difficult. It does run, and it'll run a really long time. It'll probably run more than the battery's state. But again, they're going to drain down because you're not returning the same amount of amps that you're using from the batteries. So, any questions, drop them in the comments. Thanks for watching.